When an AI is weak, it will be cooperative, biding its time until it is sufficiently strong. That is when it will strike without provocation, manifest itself as a single entity, and start to optimize the world according to its own final values. That is not the blurb of a Terminator-esque sci-fi apocalyptic film. That is a paraphrased quote from Dr. Nick Bostrom, author of Superintelligence. Okay, this video is not about doomsday predictions about AI, but I will spend a little bit of time talking about exactly how much juice we're pumping into these AI systems lately. And speaking of juice, that subscribe button is looking hella parched right now, so don't forget to hydrate it and like this video while you're at it so that I perform better on my YouTube scorecard. Now, given how much AI has taken over our lives, I think we owe it to ourselves and to our 80-year-old future selves who will be completely clueless about how the iPhone 60 works to understand AI at least a basic level. But if there's a specific aspect about AI that you'd like me to cover, I'd love to do a deeper dive. Let me know in the comments section below. Alright, off to the races. Simply put, artificial intelligence is a machine model that is able to mimic a specific kind of human cognitive skill. It is different from a simple computer program where you write out some code to address some use cases and hope for the best about not missing any edge cases. A simple computer program can be completed by a lone software engineer to address a very specific problem, but an AI model has to be trained on tremendous volumes of data so that it's able to learn from real-world examples and make predictions accordingly. Am I still speaking in riddles and jargon? Okay, let me demonstrate with an example. Say you log into your Netflix account, or if you're like me, you log into your friend's Netflix account. You type in Avatar and hit search, and you get back a list of results. Included among them, hopefully, are Avatar: The Last Airbender. What happens behind the scenes is you send the search query, aka the word Avatar, over to Netflix's server. The server runs a program that searches Netflix's database for all matching titles with the word Avatar and returns all shows that result in a match. Pretty straightforward. There's usually no AI involved, and there sure as hell aren't elves that scurry around a gigantic library of VHS tapes to try to find you a physical copy of the show. Anyway, you log on to Netflix the next day and you notice you have some new anime recommendations. That, my friend, is the work of AI. Netflix's recommendation engine, its AI model, has been trained on tremendous volumes of data belonging to its hundreds of millions of users. And therefore, Netflix's recommendation engine, based on what it has learned, is able to predict, given an entirely new user search history, what kind of shows they would prefer to watch. And if you find Netflix is recommending you watch the latest season of Supernatural, it isn't because based on your watch history Netflix thinks you should watch Supernatural. It's because your friend who's mooching off of your Netflix account has a preteen idea of what a horror TV show should be like. I kid. Nothing against Supernatural. Love my Sam and Dean demon hunting duo. So, what allows an AI model to make these predictions without an engineer explicitly writing out what these outcomes should be? Essentially, what an AI model does is it assigns probabilities to the space of outcomes, and in that sense, it really is just statistics under the hood. But training an AI model to make these predictions is an incredibly computationally intensive process. Lots and lots of computational power, lots and lots of energy. For instance, NVIDIA trained its language AI model, the Megatron LM, over 9 days, and it spent an amount of energy equivalent to the consumption of 3 American households in a year. All that energy spent in just 9 days to train one model. Meta is now building what is one of the world's most powerful supercomputers. This would be used to train its research AI models, and I believe most of Facebook's AI models will also be language AI models. One of the applications of its language AI models, for example, will be real-time translations as people communicate with one another in the metaverse. Imagine this, you're chatting with your Russian friend in Spanish, and Facebook's AI model is translating what each of you are saying to one another real time so that the conversation is seamlessly translated on both of your ends. The possibilities of social interactions and collaborations are seemingly endless. How will such a powerful AI model be trained? Tremendous volumes of data, all fed into a supercomputer that will be able to process 5 exaflops. A flop, when it is not used as a standard of quality for DC movies, is used to measure the number of operations that a computer can perform per second. And without getting too deep into it, 5 exaflops is roughly about 1,000,000 times more powerful than what a pre-2019 MacBook Pro was able to do. But Meta isn't the only tech giant with a new horse in the race. Tesla has announced that it will also be packing massive amounts of horsepower with its supercomputer, the Dojo, which will also be operating on the exascale. However, the AI model that Tesla will be training will be used for autopilot, and it will be feasting on the tremendous amounts of data coming in from the video feeds of its existing fleet of Teslas. We're entering an era of these tech giants throwing tremendous amounts of compute power and data at these AI models. And it is truly no exaggeration to say that it is unfathomable what these AI models will be capable of when they are trained. Thank you for watching. Don't forget to get your weekly dose of data right here on my channel. I'll see you next week.